Good morning, sir.
Sorry for the delay. Okay, so before we start with today's part of Simplex, can somebody do a quick recap of what we did yesterday?
Sir, can I?
Yes, Dikshant, go ahead.
Sir, we saw the simplex algorithm. We need to check the optimal CPF and all that. And then we saw basics of matrix and identity matrix, and then how to use ERT to convert a matrix into identity matrix and solve equations in 3 variables using it.
Okay, very good. So can somebody tell me what is simplex algorithm? What are the steps that we follow? Yes, Kavin, do you remember? Yes.
Simplex algorithm. Actually, I'm not so sure about it.
No problem, no problem. Aditya?
I'll just briefly say we have to start from mostly we will start from the lowest part. Like if we have 0, 0, we'll start from 0, 0 and look for adjacent feasible point. So if the adjacent feasible point, if there are 2 adjacent feasible points, we'll choose the higher adjacent feasible point and check, replace the variables, and then check the value, and then look for adjacent feasible points of that point, and then check the check. So if there are 2 adjacent feasible points for that point, we'll take the higher one, and we'll check the value, what the value it gives, and then we'll again that process will be repeating till we get the highest value of that
profit. Yeah, okay, good. Yes, Aditya, you want to add anything to this?
Oh, sir, it was honest. Yeah.
Okay, Urvi?
No.
No, okay, fine. So yes, what Kavin said is correct, and what we do as a first step, we call that step as initialization. Okay, so in initialization, basically we pick up one solution and we say, okay, this is the initial solution. So we basically need a starting point, right? So we initialize one of the solutions as a starting point, and as a rule, we said that we initialize origin 0, 0 as our first solution. Okay, then what we do, we apply optimality test. we say, okay, is this an optimal solution? If the answer is yes, we stop there. If the answer is no, then we move to the next iteration. Okay, and what do we do in that next iteration? We try to find out a better CPF, right? Adjacent better CPF. So whatever solution we are selecting, there are 2 adjacent CPF, corner point feasible solutions, and we try to figure out which one is better as compared to what we are currently at. And then once we find that out, that solution or that point becomes our initial point for the next step. So again, we go back into the loop. Okay, that is how we follow that loop again and again until we hit the optimal solution. Okay, fine, great. And okay, I guess I had given you some problems for homework. Okay, so have you guys done that?
Yes, sir.
Yes, sir.
Okay, and were you able to do that with matrix transformation?
Yes.
Yes, sir.
Anyone, is there anybody who is struggling with that part? No, everyone is comfortable. I said that maybe you can also try day one's homework questions using matrix transformation. Did anyone do that? No.
Yes, sir.
Okay, Kavin, you did. Okay, and you got the. Sorry.
Yeah, I got the same answer. I got the same answer.
Okay. Yes, Anaita.
So can you repeat the question?
I said that on day one also I had given you some homework in which there were 2 questions I wanted you guys to solve by elimination method. Okay, and then I said yesterday that if you want, you can even try solving those questions through matrix transformation, like Gauss-Jordan elimination method. So if you haven't tried that, for everybody I'm telling this, you can try that maybe even today. Okay, that would be a good practice for using those matrix transformation for solving equations. Fine. Any other question, doubt before I start with today's session? Anyone has any question? No.
Sir,
Are
can you
you-
once share your screen and show a problem of 3 variables?
Problem of, sorry, which one?
The 3 variables.
3 variables. Oh, okay, fine, sure. One moment.
And sir, if there is a matrix of x square and y, if it's a quadratic equation, then using the matrix identity method, can we find the value of x square and then root it?
It works with, as far as I know, it works with linear equations. Okay, this is,
Sir, no, we'll assume x square as say t, and then
Okay.
find the solution to t using matrix method, and then square root of t to find x.
maybe, I don't know. I never tried that. So yes, if you wish, you can try that. One moment. So this is batch A, right? Okay. You wanted to see that problem with three variables, right? One second. Okay. So yeah, some of you left early, but I guess we finished that. Maybe yeah, this one. Can you all see my screen?
Yes,
Yes, sir.
Yes,
Yes.
sir.
Yeah. So yes, this is that problem.
Okay, thank you, sir.
And,
I
yeah.
took screenshot.
Okay. Fine. Great. Now,
Sir,
yes, Madan.
sir, is it posted in classroom?
This slides, I'm sure must be there because I shared that with Neha yesterday. You're not able to see this.
Sir, it's there.
It's
Sir, it
there.
is there.
It's posted.
It is there. Yeah. Okay. Step.
Yes, sir.
Yes.
Today I will check.
Okay. Yes, Amrita.
Sir, could you please repeat the order for the three one for this
Oh,
month? Could you please repeat the order how to do
Yeah.
it?
Sure. I'll do that. See, maybe I'll use this slide. Okay. So. One zero zero 010 and 001. Okay, so first thing, see, always let whatever be the order of the matrix, whether it is 2 by 2, 3 by 3, 4 by 4, 5 by 5, what you should remember is you should always start from column number 1. Okay, then move to column number 2, then column number 3, and so on. Okay, what is column number 1? This is column number 1, right?
100.
Yes, and in column number 1, or rather in every column, when you are going to begin with that column, your first objective is to achieve 1 here. Wherever is that 1's position, okay, that diagonal element is 1, you know that. So first you should try to achieve 1 here. Okay, it's easy. There are 2 possibilities, 2 ways you can do that. If any of the row is already having 1 in that position, you can swap them, right? Otherwise, whatever element is there, just divide by that element to the entire row, and your first element will become 1. So that is step number 1 always. Then whatever other elements are there in that column, you try to make them 0 using this element which we just turned into 1, using that row. Okay, and then the same procedure you have to repeat. Then you move to the second column. Wherever there is 1 in that diagonal position, you know where 1 should be, so you first make that 1. Then, making use of this 1, that is this row, you need to turn the other elements 0, and then you move on to the third one. Get this 1 first, using this, turn these 2 elements into 0. Is it now clear, Amrita?
Yes, sir.
Okay, fine. Great. Any other questions before we? Yes, Madan.
Sir, can we do by row wise instead of column wise?
Oh, we did operations row wise only. But so are you talking about the sequence, like doing this first and then doing this and this?
There's no
Yes,
difference.
sir.
Ah, okay. See, yesterday while talking about elementary row operations, those transformations can also be applied to column. I don't know if I mentioned this in your batch or not, but whatever we did with row, the same things can be done with columns as well. Okay, so if you have to go horizontally, then you will have to apply the column operations. Okay, the column transformations.
Sir,
Okay.
if we
That is
didn't go,
yes.
if we didn't
Yes.
go horizontally, can we use the row switch method? Row switch. Like
Oh,
if we
so
are
instead of row switch, you can go for column switch, right? See, my suggestion would be, if you are using row transformations, then you can use swapping between the rows. If you are using column transformations, you can use swapping between the columns, but don't try to mix both the things, then you will go wrong. Okay, fine. So, okay, any other question before I move to the next part? No? Good. Okay, let me just share the new set of slide. Okay. Okay, so this is our problem. Yeah, we all know that, so I'm not getting into that now. Okay, there is a question for you guys. Everybody start working on this. Once you're ready, you can
Sir,
share
there's
your
two
answer.
equations. It's not.
So what? If Dikshant is saying there are two equations.
So what would be the identity matrix for this one? It's rectangular.
Oh, I didn't mention that you have to go for identity. You have to go for matrix transformation. You can use
Zero,
any
right?
other method.
The other row will be 0.
Okay. I don't know. I don't know. You guys need to decide.
Sir?
Yes.
Yes, sir. When I tried solving the actual LPP problem by this method, and yeah, that turned out to be a rectangular matrix, and that was a huge process actually.
A rectangular matrix. Okay.
Yeah, I couldn't.
I took the missing row as zeros completely,
Yeah.
and then
So Kaveen has a idea. He is suggesting that the missing row he took that as 0. Maybe I don't know if that will help you.
I will try.
How will you
with
make
0.
from 0 to? Oh, okay.
0 minus 0 plus
No.
anything into 0, 0.
No, not that. I was wondering how you make the last one 1, but you can do it.
Sir, I found the value of x, y, and z, but I didn't use matrix.
Oh, you found the solution. Okay.
But I didn't use matrix methods.
Or you didn't use matrix method. Okay, so what is your method? And first of all, what are the values?
Sir, x is 0, y is 17, and z is 10.
X is 0, Y is 17, and Z is 10. Okay. So how did you solve this, by the way?
Sir, first I added both equations. So I got x plus z equals to 10. And from that
It's
z.
2x. It's 2x.
Okay, okay. Yeah, so if I add this will become x plus x, 2x,
2x.
plus y minus y, this will get cancelled, I
Yeah.
agree. Minus z plus
2x
2z
plus
will
z
become
equal to 10.
z, and that is equal to 10. Okay,
Mistake
then
there, sir.
now.
I made a silly mistake there, sir.
Yeah, no problem, no problem.
Yeah, but anyways, you're getting x is equal to 0, so it doesn't impact.
Yeah, but how did he get x is equal to 0? That is my question.
We can substitute z is equal to 10 minus 2x.
Ah, you can substitute z is equal to what?
10 minus 2x.
2x. Okay, let's do that. Z is equal to 10 minus 2x.
X is 5, y is
So
But still it
you-
won't work. Substitution also needs 3 equations.
it would work.
where do you want me to substitute this, by the way, if I call this as equation 1?
In both the
Oh,
equations.
in both the equations.
Yeah, and
Okay.
you get 2 equations in x and y. And then you get x is 5, y is 2, and z is 0.
Okay. So this equation will become what? X plus y minus z is 10 minus, right? So plus, yeah, so minus 10 plus 2x, right? Okay, is equal to 7. Fine. And but then how did you get this z? You got this z by adding these two equations, right? You are not generating z out of any one of these equations.
Yeah.
Will that really work?
Sir, first sir, then again we can substitute y's value, sir. Then finally, when we find x's value, we can do the same for y and z.
Okay, 1 minute. So if I give you this equation, let's say 4x plus y is equal to say 18, and if I ask you find out x and y, can you do that?
Sir, it is separate from the original, or it is the same value?
No,
of x and y?
new problem. Okay, think
No,
of new problem.
sir, I can get a set of answers.
Sir, sir,
Yes,
here what we can do is y equals to 18 minus 4x.
correct.
Then 4x minus 8, 4x plus 18 minus 4x.
4x, what? Sorry, 4x plus 18.
No. Okay.
Sir, we can plot this line on the graph and get all the solutions.
Sir, it will come as 18 equals 18.
So someone said we will plot a graph and find all the values. For plotting graph, what will you do exactly?
We'll plot this equation easily. Take any 2 values of y, then accordingly find the value of x.
Exactly.
And
That's
then
an
plot.
important statement. What did you say? Take any 2 values of y and then you find out value of x. Agree? Yeah,
Yes, sir.
that's what you said. And that is how we do, right? Okay. So very important point here. Try to understand one thing. See, this is an equation, one equation. And how many variables?
2.
2 variables in it, right? And if I have to solve this, how did we do that? Even in I think in the first session, we assume value of so we said if x is equal to 0, what is the value of y, right? And then we said if y is equal to 0, what is the value of x, correct? So if you have just a single equation with 2 variables, if you want to solve that, you have to assume value of 1 variable. You all agree with this statement? That's what we did, right? Everybody
Yes.
following this, what I'm trying to say? Okay. Same way, if I have, so yesterday we did a question with 3 variables, or let's talk about another question where we have 2 equations with 2 variables. Okay, so let's say 4x plus 3y is equal to say 18, and maybe x plus 6y is equal to 12. Okay, don't try to solve this, but can I find out x and y in this case without assuming any value for any variable?
Yes, sir.
Yes. Why? Because in this case we have two equations, and how many variables are there?
Two.
Two variables, right? So Dikshant at the beginning, very beginning, he said, sir, how, he was wondering how is this possible, because there are three variables x, y, and z in this example, and how many equations are there? There are
Two.
only two equations. So for this kind of scenario, if you have to solve this, you will have to assume the value of one variable. Okay, and then only you will be able to solve that. Are you all following this?
Yes, sir.
And you all agree with yes?
But sir, is it like, how can we assume like is it
That's a different story. Okay, so how can we assume? I agree with that, but do you agree with the logic that if I assume value of any one variable to be some number, and then we'll be able to solve that? You agree with this logic? Yeah.
Yes.
Okay. So please remember this part of our discussion now. We'll be using that at a later stage. Okay, fine. So there is something called as degrees of freedom. Okay, maybe we'll be using a short form. So what is degree of freedom? Basically, that's nothing but number of variables minus number of equations. So we are talking about a system of equations, and this is how the degree of freedom is defined. So basically, when we are talking about this problem, okay, what is the degree of freedom for
One.
this? Yes, because
So we have to assume one
how many
variable.
variables are there? Three variables, x, y, and z. And how many equations are given? Only two equations. So what is the degree of freedom? One. So this degree of freedom tells you that you have to assume some arbitrary value for one of the variables, then only you will be able to solve that system of equation. Is that clear? That's what degrees of freedom mean. Okay. Now we'll come back to this little later.
Excuse
So
me, sir.
yes.
Sir, I have a contradiction. So if we are able to do it by like z equals 10 minus 2x and we are substituting that, why should we assume that?
Is z equal to 10 minus 2x is your original equation? Okay. If you want to do the substitution, okay, see, 1 minute. Okay, let's substitute, let's figure out what is x, okay, from the first equation. X will be equal to 7 minus y plus z. Agree? Yeah, I just, yeah, I'm moving everything else to the right hand side, keeping x on the left side. From the second equation, what do I get? X is equal to
3 plus y minus 2z.
Yes, 3 plus y minus 2z, right? And then I can say, okay, these both are values of x, so I can equate them. Okay, so 7 minus y plus z is equal to 3 plus y minus 2z. Okay, and then if I again simplify this, I will get something in terms of y and z. So that's the same situation like this. You have an equation having two variables. So unless you assume the value of one of them, how will you able to solve that? Are you understanding this point?
Okay.
Yeah.
So we need another equation of two variables of the same kind so that we can do it.
Yes. Yes. Okay. So now, so when I say you, let's say that if we assume x is equal to something, some value, okay, let's say x is equal to 0, for example, then what will happen? This x will vanish from the equation, and then you end up with two equations with two variables which you can solve. So you will say when x is equal to 0, y is equal to this and z is equal to this by solving this system of equation. Okay, so I'm not saying this is the only solution. I'm saying when x is equal to 0, then y is equal to this and z is equal to this. If you are assuming x is equal to 5, still can we solve this equation? The answer is yes.
Yes.
If I make x is equal to 5, this 5 will go on the right hand side. 7 minus 5 becomes 2. 5 will go on this side. In the second equation, 3 minus 5 becomes -2, and then I end up having two equations with two variables, and which we can solve. So when we write our answer, what are we going to write? I'm going to say if x is equal to 5, then y is equal to this and z is equal to this. Are you understanding my point? What I'm trying to say? Everybody clear about this now? Okay.
So if there is 3 variables and there are 2 equations, there are infinite solutions because you are assuming.
Yes. That many solutions could be possible, right? We are not sure that we can't say that this is the only same like this. If we are talking about 4x plus y is equal to 18, how many solutions are there? Or there are infinite solutions, right? For this, you agree? That's what we saw, right?
Yes, sir.
Yeah. Okay. Now, yesterday.
Sir,
Yes.
sorry, can you just move to the previous slide once?
Yeah, sure. Anaita. Anaita.
Yeah. So what we have done is necessarily we have substituted the value of z in the terms of x and y, and then we have received one equation. And
Yes.
then we have substituted a random value of x and a random value of y to gain another equation, and then we can solve those two simultaneous equations to get the values of x and
No. This is something I was just trying to show that if we find out x in terms of y and z, and then if we equate them, we end up having just one equation with two variables. If you really want to solve this, you will have to assume value of any one variable. Okay, maybe you can assume value of x, you can assume value of y, you can assume value of z. For example, if I assume value of y to be some number, I will substitute that in this both equations, and I will simplify it. So what am I going to get? I will end up getting two equations with variable x and z, right? And two equations with variable x and z I can solve. While writing answer, I'm going to say if y is equal to this value, then x and z equals to this values. Okay.
Yes, sir. That's what I was saying. That one
Yes.
equation will get derived from the all the solving
Yes,
and
yes,
substitution,
yes,
and the second one from assumption. Okay.
Yeah,
thank
yeah,
you.
right. Okay. Yes, Parul.
So we're not using matrix. I mean matrix.
No.
But is
not
it
using-
like possible? It should be, right?
what? Solving this with matrix? Oh, not possible.
So why
So
not?
what is?
So then how are we going to solve it?
Sir, I tried the using matrix and the third column 1 didn't work out.
Yeah.
Yes, sir.
Yeah.
And
Yes.
that's what I was about to say.
Yeah.
If every value in the one column, like I'll just
Zero.
annotate. Can I annotate?
Oh no,
so-
no, don't do that.
No.
You just speak. Please speak.
Okay.
Speak up.
If every value in one row or column is same, like we'll have 1, 1, 1, and 1, we'll not be able to solve. If we have two,
Okay, we will have 0, 0, 0, 0 rather.
yeah,
Because
0,
there is
0,
no
0, 0
equation.
also, we won't be able to solve.
Yes.
If every value is 1 also, every value is same itself, we won't be able to solve. 5, 5, 5, 5, we won't be able to solve it.
Okay. I don't want to get into that
Sir,
as of
sir.
now because I
Could
want to
you-
cover the simplex method. So
Sir.
yes.
Sir,
Kavina.
could you repeat what is degree of freedom equal to 1?
Degrees of freedom. Okay. So when a system of equation is there, you have to count how many variables are there. You have to count how many equations are there, and the difference between number of variables and number of equations is nothing but degree of freedom. So for example, in this case, how many variables are there? 3, x, y, and z, correct? How many equations are there? 2.
2 equations.
So 3 minus 2, 1. So that 1 degree of freedom is telling you that if you want to solve this system of equation, you have to assume the value of one variable and then you can solve it. Now clear?
If it is 2, we should assume for
You
2
have to
variables.
assume value of two variables. Absolutely correct.
Okay.
Yeah. Okay, good. Now, okay. So yesterday, on day one, rather, we saw a graphical approach for solving linear programming problem. Day two, that is yesterday, we moved to a geometrical way of looking at that problem, because as I said, the concept underlying simplex is geometric. Okay, and in that we said that instead of running through various points inside the region, we decided that we are going to move through the corner points. Okay, and now today we are moving to the algebraic way of solving LPP, linear programming problem. Now, if you remember our functional constraints, they were all inequalities. I hope you all
Yes,
remember
sir.
that. Yeah.
Yes,
Well,
sir.
what were those inequalities? Can somebody spell them out for me? First, what was first
X1
inequality?
is less than equal to 4, x2
Very
is
good.
less than equal to 6, and 3x1 plus 2x2 is less than equal to 18.
Everybody agree that these are all inequalities?
Yes, sir.
Yes,
Yeah,
sir.
functional constraints are inequality. And if I want to use the algebraic way, basically using computer, then I need to convert this inequality into equality. Okay, we need to have equation, because if I have equations, I can solve them, right? So I want to convert these inequalities into equality, and let's try to understand that. Okay. So, so these are those inequalities, right? So, okay, let's say if I tell you that x is less than equal to 10, fine. X is less than equal to 10. That means x could be, and let's only focus on the whole numbers. Okay. So x, if x could be anything, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Any value. So if I want to write this as an equality, can I introduce another variable and say x plus y is equal to, or rather x plus something is equal to 10. Okay. Now, what I did, I converted this inequality into an equation, okay, by introducing this box. And what value this box will take, that depends on what value x is having. For example, if x is 2, or the value in the box will become 8, right? And my equation will be true. If we are saying x is 5, oh, what is the value in the box? Oh, that becomes 5. And
So if
my
x is
equation
10, then box is 0.
Very good. If x is 10, then box is 0, right?
And x
So,
can also be 0, right?
yeah,
In
and
the
x can
box.
also be 0. If x is 0, then box becomes 10, right? Right. So that means this box can assume different values depending on what is the value of x, correct? So what is that? I can simply use a variable for that, right? So I can write this as x plus y is equal to 10. Are you all okay with this? Are you understanding
Yes,
how we
sir.
can convert an inequality
sir.
into equality simply, right? And then we are going to define that since I want y and x both to be whole numbers, I'm going to say x must be greater than equal to 0 and y must also be greater than equal to 0. So which will not allow us to take any negative values. Everybody fine with this? Yes, Madan?
Sir, if the inequality is like this, means what we should do? If x is greater than equal to 10, then
Okay. So let's take an example. X is greater than equal to 10. That means x can be 10, 11, 12, 13, 14, right?
So it's
Agree?
x minus y
Subtract.
equal to
X minus
Very
y
good.
will be equal
We
to
can
10.
write x minus y equal to 10. So if x is 10, y will become 0. If x is 15, y will become 5. Okay, clear? Madan?
yes, sir, understood. Sir, but instead of less than or equal to and greater than or equal to, there is only greater than, means that is not possible.
that is not possible. Okay, so
Sir, why is it
oh
not?
yeah, because see, okay, so yes, someone said why is it not possible?
Yes.
So if we have x less than 10, then can we convert this into an equation?
Yes, sir. X plus something equals to 10.
Can I convert this? See, I know how to deal with this kind of inequality, less than equal to, right? But we don't know how to deal with this. But can I convert this into something similar which I know? Can I write
X
this as
plus
x?
No,
No,
minus 1 is
no, a simple thing. Can I say x has to be less than equal to 9?
Yes, sir. Yes, sir. That's
Yeah.
all.
yes,
That's it,
sir.
right?
But
We
it
are done,
can't
and then we know how to deal with this. Okay, so this can also be, this is same as these two are same, right? You agree? When we say x has to be less than 10, that means x can be 9 or any value less than 9.
But
So
only
here you're
like
taking
the
all
whole numbers.
Yeah, of course.
Yeah.
We are talking about whole numbers, right?
Okay.
Okay, yeah, great. Now, since you guys have understood this, 1 minute, I want to get rid of this. So I don't remember who tried doing this annotation. Kaveen, was that you or someone else?
Yeah, it's
Is it possible for you to delete that, erase that? Because I'm not able to do that. I don't know.
yeah.
Just check. Yeah, thank
Yeah.
you. Thank you.
No, sorry.
No problem. Okay, now, so these are our functional constraints, right? And they are all inequalities. Now I need to convert them into equality. So what does that mean? I have to introduce another variable, right? So now pay
X1 plus
attention.
Y1 is less than is
Yeah.
equal to
So
But the
we will
third
equal to
equation
4.
already
we
has a
will-
second variable. Right?
yeah. So we are using two variables already, right? X1 is the quantity of Astra and X2 is the quantity of Leo. So we call them as decision variable, right? Decision variable. We can't use these letters again, of course. So we will continue this series. So the next in the series is X3. So what I'm going to do is I'm going to say, okay, this inequality, if I'm convert that into an equality, I'll get X1 plus X3 equals to 4, right? For this one, I'll say 2x2 plus x4. I'm using, I can't use x3 everywhere, right? I hope you agree, because
yes,
sir.
yeah, it has to be different. So I'm using x4, which is equal to 12. And for the third one, 3x1 plus 2x2 plus x5 is equal to 18.
18.
Everybody clear with this step?
yes,
Yeah.
Yes, sir.
yes, sir.
Okay.
Sir,
let's-
instead we can use x and y instead of x1 and x2.
Yeah, you can use x and y as well, no problem. Okay, so
Variables only there.
yeah, we have been using x1 x2, and I have shown those axes with x1 x2, and then the other variables as x3 x4 x5. So see, when it comes to your curriculum, mathematics, and you will come across these kind of problem, you will see x and y being used, and for these variables, the letter which is generally used is s. So these variables here are called slack variables. Okay, slack variables, and then the letters used will be s1, s2, and s3. Okay, but anyway, that will not make much of a difference. Our focus is on understanding the concept. Once you understand the concept, whether it is x1, x2, or x or y, or y1, s1, doesn't matter, right? So let's move on now. Okay, so pay attention to this. This was our left hand side is our original form of model. What was that? Maximize this function, right? 3x1 plus 5x2 subject to these conditions, and these conditions we call them as functional constraints, and they were all inequalities. And non-negativity constraint. Okay. And now we converted these inequalities into equations, and this form is called the augmented form of the model. Okay, augmented is modified. Basically, we modified it with some additional variables. Okay, what are
Sir,
those
are we going to
variables?
use matrix to solve this now?
We are, but wait, hold on. There is still time for that. Okay, and then these are those new slack variables which we have introduced to convert these inequalities into equalities. Okay, and each one of them, including x1, x2, has to be greater than equal to 0. So that non-negativity constraint is applicable for each one of them. Therefore, we say xj greater than equal to 0. What is j? J is 1, 2, 3, 4, 5. So that means x1 is greater than equal to 0, x2 is greater than equal to 0, x3 is greater than equal to 0, and so on. Everybody clear about this? No confusion?
No, sir.
Sir, we don't have to include the non-negativity constraint in the table, right?
No. That is taken care of here, right? This is nothing but your non-negativity constraint. Instead of writing each one of them separately, we are generalizing xj greater than equal to 0. What is j? J can take values 1, 2, 3, 4, 5 because we have 5 variables. Okay. Now let's move on. Okay. So in this case, when we were getting a solution, what was our solution? So for example, one of the solution was 2, 6, right?
Yes,
or
sir. Sorry, it was
whatever, 2, 6, right? Yeah. So what was this? What was this? X1 is 2 and x2 is 6, right? When we are going to talk about a solution for this, okay, we call that as an augmented solution. So now our solution is not just 2 variables, but we have introduced 3 more variables. So if I want a solution here, it's going to be in this form: x1, comma x2, comma x3, comma x4, comma x5, right? So it's going, this is called an augmented solution because we are using an augmented form of the model, and from that whatever solution is going to come out, it's not going to be just 2 values, but it's going to be a set of 5 values. Are you all clear about this point?
Yes, sir.
Okay, fine. Now, okay, let's try to find out, or maybe we should directly move to this. Okay, now let's try to work on this problem. We all are familiar with this diagram, right? We all are familiar with this diagram.
Yes, sir.
So this is the augmented form of our equations, and I want all of you to find out the augmented corner point solution. So for example, 0, 6 is one of the corner point solution. You all agree? 0, 6 is one of the corner point solution, right? Now I want to find out what is the augmented form of this. So that means it must have, so these are values of x1 and x2. I want to know what is going to be the value of x3, x4, and x5 for this point.
Sir, x3 is 4.
Yeah,
and,
1 minute. Let's go slowly. Let everyone follow that. Okay. So let's start with this solution.
Draw 5 axes here instead of
no. Don't draw 5 axes or anything. Just pay attention. Okay. We start with this solution, right? Which is our normal corner point solution, and this is telling you that x1 is equal to 0 and x2 is equal to 6. Are you all with me on this?
Yes, sir.
Okay.
Yes, sir.
Now to find out what we need to find out augmented solution, I need to know the value of x3, x4,
That's
and
4 and 0,
x5, right?
and
This is what we want to find out. Oh, how am I going to do that? Oh, we have these 3 equations, right? So equation 1, what is this equation? Let me write down that. X1 plus x3 is equal to 4, correct? But what is the value of x1? We
0.
already know that, 0, right? So if I substitute that here, then can I say x3 is equal to 4?
yes, sir. Yes, sir.
Okay, so I got x3.
Yes, sir.
Fine. Let's use the second equation. What is the second equation? 2 times x2 plus x4 is equal to 12, right? That's the second equation.
X2
Out of
is
that-
equal to 6.
Very good. You already know x2 value, right? So substitute that. 2 times 6 plus x4 is equal to 12. So 6 times 2 is 12. 12 minus 12, 0, right? So x4 becomes
5 is 6.
0. Okay, yeah, 1 minute. And then let's use the third equation. So 3x1 plus 2x2 plus x5 is equal to 18, right? Okay. X1 is 0. So can I simply assume this term will become 0?
0. Yeah.
2 times x2, or x2 is 6. So 2 times x2 will become 12.
12
Plus
plus
x5
x5.
is equal to 18. That means x5 will be 18 minus 12, that is 6, right? So we say this solution 06, which is a basic solution, the augmented form for that, so 06 is same as, this is same as in augmented form.
06406.
X3 is 4, x4 is 0, and x5 is 6. Everybody
Sir, for
comfortable
the-
with this? 1 minute,
Sir,
1 minute, 1 minute. Everybody comfortable with this?
Sir,
Understood? Yes, yes, Anaita.
sir, I got it how it happened, and I got how we calculated the augmented form.
Yeah.
Why is that so?
Why is that so? Yeah, we'll come to that. We'll come to that, because see, why are we having these extra variables now? X3, X4, X5?
To make the inequality to equality.
Yes, because we want to shift to the algebraic way of solving problem. In algebra, we can solve these equations. Okay, and for having equations, we had to convert those inequalities into equalities. Therefore, we have to introduce these variables. And if we are introducing those variables, then we must know what are the values of those variables, right? So that's the reason we are now going to have this augmented form. Okay, now if everybody is clear about this, then 06 is an feasible corner point solution, right? It's an CPF, corner point feasible solution. So this is also an feasible augmented solution. Let's take another example, 4,6. Where is 4,6 here? 4,6 is infeasible solution, right? It is an infeasible corner point solution. So can you all quickly find out what is the augmented form of this solution? Following the
X3
same
is
process.
equal to 0.
1 minute.
Sir, x5 becomes negative.
Oh, that's okay. That's okay. Whatever is the value.
Sir, 0, 0 and minus 6.
Yeah, but there's a
So let-
non-negativity constraint, right?
1 minute, 1 minute. So let's do that quickly. What do we have already? X1 is equal to 4, right? And X2 is
X2
equal
is
to
6.
6. Okay. What is the first equation? X1
X1 plus X3 is equal to 4.
to 4. And since we have X1 is equal to 4, okay, so 4 plus X3 is equal to 4, which will give me X3 equal to
0.
0. Okay, we got X3. Now let's think about
This will help us in figuring out whether it's a feasible solution or not.
2x2 plus x4 equal to 12. Okay, what is we know
X2.
x1 and x2, we know x2. Okay, so 6, 12, this will become 12, right? Plus x4 is equal to 12. That
X4
means
is
x4
also
is equal to
0.
0. Very good. Okay, and now the third equation, 3x1 plus 2x2 plus x5 is equal to 18. 3x1, x1 is 4, so 4 3s are 12. 2x2, 6 2s are 12, plus x5 is equal to 18. So x5 is equal to 12 plus 12, 24, 18 minus 24, that's negative
Minus 6.
6.
Minus 6.
So what this negative 6 is telling you? Someone said, oh,
It's
what
not
we need to have
It's
a
not infeasible solution because
Do you
X
see
is
that
greater
here,
than
right?
0.
Yes, you see that here. It's an infeasible solution. Everybody clear about this?
Yeah.
So
Yes,
if you
sir.
look at all the feasible points, all values of x1, x2, x3, x4, x5 are going to be positive or 0. They'll follow the non-negativity constant. But the moment you step out of that region, then one of the variables will become negative. Clear, everyone? Yeah.
Yes.
Okay, great. Now,
Can I-
degrees of, yes, sorry. Yes,
Sir,
Aniket. Yeah, go ahead, Aniket. Hello. You want to ask something, Aniket?
No, sir, I just needed to copy this because my
Oh.
pen's empty.
Okay, okay, okay. So are you done? Or maybe take the screenshot.
Okay, sir, I'll take that screenshot.
Yeah. Fine. So degrees of freedom we already spoke about, right? Degrees of freedom. So for our problem, what is the degrees of freedom?
Number of
Think about it.
variables is 5.
Sorry.
Very good.
2.
Sir, 2. So we
Number
need to
of,
assume 2,
okay, 1 minute.
which we are doing already.
Very good. Degrees of freedom. We say it is number of variables minus number of equations, right? So in our case, how many variables are there? 5.
5.
How many
Five
equations
minus
are there?
3.
3.
Which
So
is
the
2.
degrees of freedom is 2. This is telling us that if you want to solve this system of equation, you will have to assume the value of 2 variables. Then only you will be able to solve this. Are you all clear about that?
Yeah.
Yes.
Are you all understanding
Yes.
this point? Okay. We will be able to solve this only if we assume value of 2 variables. Then only it's possible to figure out the solution for this. Okay. Now these variables, we are going to put them, we are just giving them 2 different names, 2 categories. Okay. Non-basic variables and basic variables. Okay. So whichever these 2 variables, we know that I have to assume the values for 2 variables. So those 2 variables for which we are assuming values, we call them as non-basic variables. Okay, those 2 variables. And how many variables will be remaining? 3 variables will be remaining. So those 3 variables are nothing but we call them as basic variable. And what we do for those 3 basic variables, we will solve this system of equation and we will find out what is the value. I will repeat one more time. How many total variables are there? 5, right? How many equations are there? 3. So what is the degree of freedom? 2. 5 minus 3, 2. What this 2 is telling me that if I have to solve this system of equation, I have to assume the value of 2 variables.
So the 2 non-basic variables are x1 and
those
x2.
2 variables for which I am assuming value, I'm going to call them as non-basic variable. Okay. And the remaining 3 variables, I'm going to call them as basic variables. And I'm going to solve the system of equation to find out the value for these 3. Are you clear about this logic?
Yes.
Everybody?
Sir,
Yeah.
what if we add a 4th equation in this on the right side on the top, but like there was no inequality, so it just stayed the same way. That time the number of the degree of freedom will be 3,
will
right?
become so if you have 4 equations and 5 variables, then the degree of freedom will become 1.
Sorry, 1. Yeah.
So
that
you assume
time,
one value and then other, so that one will become non-basic, the other remaining will become
Sir,
basic.
non-basic are the x1 and x2 now.
So okay, that's a good question. Now, which variable can be non-basic and which variable can be basic? So there is a complete freedom what you can call as non-basic and what you can call as basic. Okay, now very interesting point. So try to understand one point. In simplex, as a rule, see what did we say? The 2 variables, these 2 variables, degrees of freedom 2, that means we have to assume some value for 2 variables, right? These are, we call them as non-basic. What value can I assume? I can assume any value, right? You remember our discussion
Yes, sir.
in the
Yes,
morning?
sir.
We said, oh, I think I deleted that. Okay, we said that if x is equal to 0, then this is the value of y and z. If x is equal to 5, then this is the value of y and z, correct? So I'm free to assume any value, right? And I can assume any arbitrary value. So in simplex, as a rule, it is decided that whatever non-basic variables are there, the value of those variables, those two variables, is going to be 0. I'm making it clear again. In simplex method, the non-basic variables, the value for them will always be equal to 0, because we are free to assume any value, and we have decided that we will assume those values to be 0. Everybody clear about this? So if you remember discussion of yesterday, day before yesterday, whenever we are starting to solve the problem, the initialization step, we start from origin. So that origin is telling me what? X1 is equal to 0 and x2 is equal to 0. Do you agree with that?
Yes, sir.
Okay. So
How to find which variables are non-basic variables?
Yes, I will come to that. So for the first step, are you all clear? How do we find which variables are non-basic? For the first step, as I said, we start from origin. And if I'm starting from origin, then automatically can I say x1 is equal to 0 and x2 is equal to 0 at origin?
Yes, sir.
Right?
The variables which were initially in our equations and which we added after that, like
Yeah, so these are our decision variables. In short, these are our decision variables. Okay, so we begin with our decision variables to be 0. So those are the non-basic variable for the very first step. Always remember for simplex method. Okay, this notations. Shriram, sorry, who's the coordinator? Shriram, are you there in this session?
Yes.
Yeah, Shriram, can you please, these notations, can you please mute them? Okay, so are you all clear? If x1 and x2 are non-basic, what are the basic variables in that case? X3,
X4,
X5,
X5.
and X5, right? Okay. Non-basic variables will always be equal to 0. Now coming back to our this solution. Look at this solution. Look at this solution, and can you figure out which are non-basic variables in this?
X1 and
X1 and X4.
Very good.
4.
X1 is 0, so this is non-basic. X4 is 0, so this is non-basic. And these
Sir, I get
three,
now how to find.
yeah, okay. So don't worry much about this now, but we will solve this step by step. But are you all clear about the non-basic and basic variables?
Sir, we can find the 5 corner points of
Sir, can you explain
Yeah,
basic
wait,
and
wait.
non-basic again?
Sorry, yes.
Can you explain basic and non-basic again?
Sure. See, we know in our system of equation there are 5 variables, but we have only 3 equations available with us. So we know that we can't solve them directly. So if I take the difference between the number of variables and number of equations, the difference is 2, right? We call that as degrees of freedom. So degrees of freedom allows us to choose 2 variables and assign them some arbitrary value. Then only you will be able to
So
solve.
we are assuming a value.
Yes, we are going to assume a value. Okay, and that value can be anything in general. But when it comes to the simplex method, that value is always equal to 0. Okay, so whatever
sir,
that arbitrary value we are assuming, that value will always be equal to 0. And those, for this specific problem, we have 2 degrees of freedom. That means 2 variables are going to be non-basic variable, and those variables will always be equal to 0. Which are those 2? That will vary for each corner. Okay, but to begin with, we start with x1 equal to 0 and x2 equal to 0. That's at our origin. So that's our starting point. Clear now?
Excuse me,
So
sir.
in non-basic, we get two variables and we have to assume both of them are 0.
0, absolutely correct. And
What
whatever
if it's
remaining,
basic?
whatever the remaining variables are there, we will find out the values for those variables using these equations.
Excuse me, sir.
Yes, 1 minute, 1 minute. Yeah, go ahead. Sorry. Go
So
ahead.
here x1 equal to 0 and x2 equal to 0, but
Correct.
later on we found that x1 equal to 0 and x4 equal to 0.
So there are different values. Yes, I agree. So as we move on with the iterations, this situation is going to change. So now x1 and x2 are non-basic. In the next step, we will have to increase the value of x2, for example. Okay. So x2, if I am increasing the value of x2, it can no longer stay as non-basic. It has to move in that other bucket of basic. Okay. So if x2 is moving to the bucket of basic, something else has to move from the bucket of basic to non-basic. And which one is that? Yeah, 1 minute. Which one is that? That is something we need to decide, because there are 3 variables. So I need to figure out which variable I should push back as non-basic out of this bucket.
Step 1 is
Sir,
x1
instead we
and
can take
x2
all
equal to 0
possibilities of 2 variables as 0, then discard one
Wait,
which contain negative, and that will give CPF.
Wait. We'll go through that process and then things will be much clearer.
So
Yes,
step 1 equal to step 1 is x1 equal to 0 and x2 equal to 0. Step 2 is x1 equal to 0 and x2.
Oh, the step 2 we will go to that. Wait now. Okay, are you all clear until this point?
Sir.
Yes.
Yes, sir. So basically, the thing we did graphically, we started from 0.
Exactly. So we started from 0 there, right? You remember 0 was our starting point. So the reason is that we want our decision variable to be non-basic at the beginning. Okay. So for the first step, I don't need to do any calculation. Why I'm saying that, I will show that in a while. Why we don't need any calculation. Okay. So let's move on now. Okay, let's okay. Okay, adjacent basic feasible solutions. Now we know that this solution and this solution, they are adjacent, then 0, 6 and 2,6 is adjacent. But now we are talking about this solution not just having 2 variables but having 5 variables, right? And those variables are divided in 2 buckets. Which 2 buckets?
Basic and non-basic.
Yeah, non-basic and basic. Okay, how many non-basic variables are we going to have? 2, right? So I'm just making 2 boxes here. Okay, how many basic variables are we going to have? 3 for our example. Now, when are we going to say that the 2 solutions are adjacent? So for that, condition is all the non-basic variable except 1 should be same. Now in this case, there are just 2. So basically, let's say this is my solution 1 and this is my solution 2. So this solution will also have 2 non-basic variables and 3 basic variables. So now if I tell you that in solution 1 and solution 2, this and this, they are same, but the other non-basic variable is different. Okay, then we can say these 2 are adjacent solutions. Are you understanding what I'm trying to say?
Yes, sir.
Yeah?
So all this is doing algebraical than graphical.
Yes. So see, I'm saying I have 2 solutions. First solution, these 2 boxes are representing the non-basic variable. These 3 boxes are representing the basic variable. In the second solution, there is one more solution. Okay, these first two boxes are representing non-basic variables. The other 3 are representing basic variable. When do we say that these 2 are adjacent solutions? When all but 1. So that statement is confusing, so I'm trying to simplify. I'm saying out of these 2, if one of the variable is exactly same in both these, then we say these 2 are adjacent. If both are same, what does that mean? Oh, we are talking
Same
about the same
solution.
solution. Yeah, we are talking about the same solution. We are
Okay,
not
this
talking
2,
about two
6
different
and
solutions.
6, 2 means
Right.
it's not right.
Okay, so in adjacent solution, one of the non-basic solution has to be same, the other one would be different. And when I make this statement, can I say it? This also implies one of the basic variable will also be different. The two basic variables will be same, but one of the basic variables will be different. Are you understanding? Because this entire solution is made up of 5 values. If one value is different in non-basic, then one value has to be different even in basic.
Why can't be two values different in basic?
Why can't be two values? If two values are different in basic, where those two variables will go? Those two variables has to go into the bucket of non-basic, right? And that means in the two solutions, both the non-basic variables are different. And if both non-basic variables are different, are they adjacent solutions? The answer is no.
So
right?
we are moving
the answer is no.
variables from basic to non-basic.
Yes. Okay. So now let's start working on this. Okay. So you all are familiar with the simplex algorithm. Okay. Let's start with the problem. This is going to be slightly complex, so you guys need to be patient and pay attention. Okay.
Sir, before starting, can I just ask a doubt?
Yes, go ahead.
Yeah, so we said that when two non-basic are same in equation 1 and equation 2, we say that they are adjacent. How is that so?
Oh, I didn't say two non-basics are same. There are two non-basics. Out of that, one has to be same and one has to be different.
Yeah. So how will that help? I didn't
How
get
yeah.
it.
So hold on. We'll come to that. Now, using this information, I'm going to tabulate this information. Okay. So maybe if you guys want, you can start doing that with me, or if you want to pay attention, just pay attention and then take a screen grab later. Okay. So what I have additionally done is our objective function. Okay, 1 minute. Our objective function is this, right? What is our objective function? Z is equal to 3x1 plus 5x2, right? Okay. So I'm just rearranging the term, and can I rewrite it as Z minus 3x1 minus 5x2 is equal to 0? Can I rewrite it like this?
Yeah.
If I move everything else to the left hand side. Okay, so I'm calling this as equation 0, and I'm going to use that also in this, because this will help me in getting the value of Z with every step. I don't need to do then separate calculation. How? We will see that in a short while. Okay, but I have introduced another equation, and I'm purposely calling that as 0, because for us, for solving system of equation, we will focus on this 1, 2, 3. This 0 equation is going to help us to get the value of Z directly. Okay.
So Z is another variable we have to consider.
Z is our profit, right? Z is profit.
So it's a constant, not a variable.
What is profit?
It's a variable, right? It's a variable. The value of Z depend on the value of x1 and x2. Right?
So it will.
Sorry?
It will increase our degree of freedom.
Oh,
Okay,
so that's the reason. That's the reason I'm calling this as 0, and keep this equation out from whatever we are trying to do. Okay, so I'm not adding any extra equation on our system of equation. That's the reason I'm calling this as 0. So this is not going to hamper our degree of freedom. Don't worry about that. Okay, now let's move on. Fine. So I'm going to make a simple table starting with all the variables on the top. So since we have introduced this equation 0, I'm also using Z. Basically Z. Okay, I think maybe I'll just use this. So okay, Z, and then x1, x2, x3. If you want, you can start making this along with me. Okay, and then we also have the right hand sides. So I'm writing RHS. Okay, then So, okay, fine. Maybe we can drop a line here. Fine. Now, the first equation, zeroth equation. So I will denote that with 0 like this. Please try to understand how we are making this equation. So in the for zeroth equation, what is the coefficient of z? 1. Right? I'm going to enter the coefficients now. Okay. What is the coefficient of x1?
minus 3, sorry.
Minus 3. What is the coefficient of x2?
Minus
5.
What is the coefficient of x3?
0. We can take all three
x3
zero
is
now.
not present, right, in the zeroth equation. So I can say the coefficient is 0. 0 times x3 is 0, right? 0. Can I also say x4 is 0? And x5 is 0. What is the right hand side of that first equation?
0.
0. Very good. Okay, let's move on to the equation 1. Okay. What is the coefficient of z in equation 1?
0.
Z is not present there, so 0, right? What is the coefficient of x1?
1.
Very good. What is the coefficient of x2?
0.
Not present, so 0. What is the coefficient of x3?
1.
What is the coefficient
And
of x4?
0, 0.
0. What is the right hand side?
4.
4.
4. Okay. Let's move on to the equation 2. Coefficient of 0. Coefficient of z.
0.
Coefficient of x1.
0.
Coefficient of x2.
2.
Very good. Coefficient of x3.
0.
Coefficient of x4.
1.
Coefficient of x5.
0.
0, right? And x5 is not present there, right? So 0. What's the right hand side?
12.
12. Okay. Let's move on to the third equation. What's the coefficient of z?
0.
x1.
3.
x2.
2.
x3.
0.
x4.
0.
x5.
1.
Right hand side.
18.
18. Okay. What did I tell you in the beginning? That this is our initial step, right? First step. So which two variables are non-basic?
X1 and X2.
X1 and X2, right? So let me just put a circle around them. Maybe, okay. So X1 and X2 are non-basic variables, right? So what is the value? X1 is equal to 0. X2 is equal to 0, right? Fine, everybody?
Yes, sir.
We said that if we have to solve the system of equation, we have to assume value of two variables, and we call those variables as non-basic. And what is the value that we assume for non-basic? Always 0. And for the first step, as I said, we start from the origin, which is 0, 0, which automatically gives us x1 is equal to 0, x2 is equal to 0. Fine, everybody? What does that mean? Now we have assumed the value of x1 and x2 is equal to 0. So from the available information, now we are going to solve this system of equation to figure out what is the value of x3, x4, and x5. Are you all understanding what I'm trying to say? And z. 1 minute. So now just let's finish that part about z. Focus on the first line. Okay. This is not going, basically purpose of having this line is to track the right hand side. So what is the value of z now? 0. Why? Because x1 is 0 and x2 is 0, right? So at the origin, what is going to be the profit? 0. Fine. What is remaining now? If you look at that very carefully, maybe let me just highlight this part. So these are our basic variables, right? x3, x4, x5, for which we have to solve this system of equation. Is it
Sir, I have a
looking
doubt. What does maximizing an equation mean?
maximizing an equation? What we are maximizing profit. not
Sir, it's
maximizing
an
the equation.
identity matrix.
So is this something familiar to you?
Sorry, x3 value
Of
is
course,
4,
sir.
value is 12 and
Aha.
x5 value is 18.
Very good, very good. So from this, can I directly say that x3 is equal to, please help me, what is x3?
4.
Right?
Sir,
Everyone
but
is
no,
understanding.
no.
No. Okay, 1 minute. We'll check that. We'll check. I know what
Yeah,
doubt
sir,
you have.
but then X1 is also there,
Then
right?
x1,
1
x2
minute, 1
becomes
minute, 1 minute,
0.
1 minute, 1 minute. x4 is equal to 12 and x5 is equal to 18. Now, some of you might have a doubt in your mind, sir, but on the left hand side, in some equation, there is x1, in some equation, there is x2. What about that?
But that will turn to 0 because
What is the value of x1? 0. What is the value of x2? 0. So let's think about one of them. Let's take equation 1. Okay, I'm writing it here. From this, if I want to convert back into the equation, what do? 0 times z. Oh, that's 0. 1 time x1. I can keep that as 1 time x1.
What
Plus,
are we doing here?
1 minute. I'm just looking at first equation because some of you have the doubt about what about this x1 and x2. They have some values here, and still I'm writing directly x3 is equal to 4, x4 is equal to 12, x5 is equal to 18. How is that possible? So I'm trying to answer that. Are you all clear about that part? Even this one is there. Okay, let's look at this first equation and turn it back into the equation. So let me even write the z here. 0, these are the coefficients, right? These are the coefficients and these are the variables. So we multiply them. So 0 times z. I will write down that step. 0 times z plus 1 time x1, right? Plus 0 times x2 plus 1 time x3 plus 0 time x4 plus 0 time x5, and then on the right hand side we have 4. Okay, 0 times z is 0. 1 time x1 is how much?
X1.
But what is the value of x1? x1 is
Zero.
equal to 0.
Zero.
So can I say this term will also become 0?
Yes, sir.
Okay. What about 0 time x2? Oh, that's 0 already. I don't need to worry about that. Fine. What is 1 time x3? That's just x3.
1. Oh, sorry.
What about 0 time x4? 0.
0, 0.
0
0
time
plus 0.
x5?
0, 0.
And then we have 4.
Equals 4.
Everything is wiped out. Only we have
X3
x3,
is
which
4.
is equal to 4. Are you guys now understanding these non-basic variables? Because they are having value 0, we don't need to worry about even they have these coefficients here. They will turn into 0, right? And then what we are left with is our wonderful identity matrix, and on the right hand side we have the values, and hence I'm saying
So this is for the when non-basic is x1 and x2.
Yes,
origin.
this is correct. For the first first step, that is our initial initial step, right? Are you all clear with this point so far?
Yes, sir.
Sir,
Okay.
I have a doubt.
Yeah, go ahead.
Sir, I did not quite understand why you separated the first row.
Oh, I just wanted to exhibit that. How did I say confidently that x3 is equal to 4, x4 is equal to 12, and x5 is equal to 18, even though there were some coefficients for x1 here, some coefficients for x2 here. So if I convert this back into the equation, I know this one x1 is there in the equation, right? But that one x1 will become 0 since the value of x1 is 0. Okay, so it doesn't matter. That's the point I'm trying to say. Okay,
Yeah,
are you all clear until this point? So if I ask you what is this solution, augmented solution, do we have all the values of x1, x2, x3, x4, x5? Yes, we do have. So what is that solution? 0,
0, 0, 4, 12, 18.
4, 12, 18. So if we talk about the origin, for the origin, this is the augmented solution. Okay, what is the profit? Oh, I can see the profit here in the right hand side, 0. Okay, so z is equal to 0. So then I ask the next question.
Sir, from where, how did you find profit?
That's my first equation, right? That's my first equation, zeroth equation rather.
Oh.
Okay, yeah. Now I ask a question, is this profit optimal? The answer is obviously no, right? And then we say, okay, then what is the next step? I need to decide which direction I should move. Okay, so
In
now,
Leo's direction, x2.
now look at the coefficient of x1 and x2 in the table. Okay, the coefficient of x2 is higher. Forget about the negative sign for time being. Then can I say the x2 coefficient is higher? So I know the improvement rate is better in x2. So I have to bring this. So let me just put a rectangle around this. I want to bring this x2 into the solution. We call this as the entering variable. Okay. What was x2 in my first step? Non-basic or basic?
Non-basic.
Right. Now I want x2 to become basic variable because we are going to increase the value. What is the value of x2 here? 0. But what we are saying, oh, I have to increase the value of x2 to increase profit. And if I increase the value of x2, x2 no longer will stay 0. If x2 is no longer 0, that means x2 can no longer be a non-basic variable. Agree?
Sir, so non-basic variable has to be 0.
Has to be 0. Has to be 0, right?
Variable.
Correct. So now, yes.
It is called as
But sir,
entering
here we are
variable.
considering like it's -5 right there, so it's the smallest number possible.
So that -5, because the equation we have just modified. What is the original equation? Z is
Yeah,
equal to
3x. Yeah, 3x1 plus
plus
5x2 is equal to
5x2, right? So if I know, if I take one batch of x, my profit will go up by 5. But if I
Right.
take one batch of x1, profit will go up by 3. But because we modified the equation, now we are getting number -3, -5. So we keeping those signs aside for time being, look at the number and look at their absolute value. So which number is bigger? 5 is bigger. So I'm selecting x2. Clear now?
Yes.
Okay, so we know that x2 has to come out of non-basic and get into the bucket of basic variable. What does that mean? One of the basic variables has to become a non-basic variable. Do you agree?
Yes.
Yeah.
Yes,
Okay.
sir.
Now, which one is that? That is something we are going to decide. Okay, we are going to
X4.
understand.
X4.
Yeah. But how are we going to decide that? Let's try to understand the logic part of that. Okay. Are you? Yes, Omkar.
We have only 2-3 minutes.
Okay. And when is the next session for these guys?
It is at 10:30, I think.
10:30. Okay. So is it okay if I extend for some more time, guys?
Yes.
Yes,
Yes,
sir.
sir. Yes,
Okay.
sir.
Yeah, fine.
Yes,
So
sir.
now let's try to understand. So we realize that I have to move x2 out of non-basic bucket. So that will become a basic variable. But to do that, I have to move one of the basic variable into non-basic bucket, right? So which variable out of x3, x4, x5? Let's try to understand how are we going to decide that. So 1 minute. So I need this table. Okay. Let's go to the next slide. Okay, fine. Sorry. Now, the same table I'm just referring here. I'm just writing those basic variables of our first step on the left hand side. Oh, so this won't go away. Now, we got from the first equation x3 equal to 4, right? From this one, we got x4 equal to 12. From this one, we got x5 equal to 18. So these are our basic variables, and these two circled with red are non-basic, right? Now we know x2 is moving out from non-basic, and we want to know which variable should become non-basic out of x3, x4, x5. Okay. So now everybody, now important part, please pay attention. So x1 is still basic. Do you agree? Oh, sorry, x1 is still non-basic. Do you agree?
Yeah.
I'm not doing anything with x1. So x1 is
Yes,
still
sir.
equal to 0, right? What is the value of x2? Oh, I don't know that. I don't know that. It is definitely not 0 because I have to increase the value of x2 to increase my profit. So I don't know what is the value of x2. Okay. Now let's look at the first equation. What is the first equation? x1 plus x3 is equal to 4. Okay. Any change in the value of x2, is this equation govern that? Is this equation
No.
having any
No.
control
No,
over
sir.
x2 value? No, because x2 is not present here, right? So we don't care about this equation. I move on to the next equation. What is that? 2x2 plus x4.
It does matter over here. And
It
even
does
in this
matter, right? It does matter. So if I change anything into x2, this equation will have effect, right? Now let me modify this equation. I'm keeping x4 on the left hand side and getting the other term on the right hand side. So this becomes 12 minus 2x2. Are you all with me? Very simple.
Sir, we need
right?
to make x4 0 now because we have
One
to
minute,
get
one
it
minute,
into
one minute,
non-basic.
one minute. Do we have a non-negativity constraint even for x4? We have
Yeah.
defined that
Yes.
x4 has to be greater than equal to 0. Do you agree? Everybody
Yes,
agree
sir.
with this? And what is x4? x4 is 12 minus 2x2. So I'm replacing this x4 with this term. So can I now say this has to be also greater than equal to 0? I just
Yes.
replace x4 with this. Okay.
Yeah,
Now if I
basically
solve this,
express.
yeah, if I solve this, I am adding 2x2 on both sides. I will end up getting 12 is greater than equal to 2x2, right? And if I now divide both sides by 2, what am I going to get? 6
6 is
greater than equal to x2, right?
x2.
I'll just write x2 on the left hand side to make it easy. So can I now say x2 has to be less than equal to 6? Do you all understand this step?
Yeah.
Yes.
Yes.
So
Yes, sure.
this is giving me a kind of limitation. I can't increase x2 to any value. x2 has to be less than equal to 6. If I go beyond 6, what will happen?
The
What will happen?
non-negativity constraint won't hold.
X4 will become negative. Now when x2 is 0, if I put 0, sorry, when x2 is 6, 6 times 2, 12. So what is the value of x4?
0.
But I can't go below 0, right? We know x4 has to be either equal to or greater than 0. So the limiting value for me for x2 is 6 from the equation 2. Are you all understanding this? Yes, Anahita?
Yes.
Yes, sir. So we tried this for equation 2. So for equation 3, will we get a different
Yes,
value?
yes. I'm coming to that. So let's go to equation 3. What is equation 3? 3x1 plus 2x2 plus x5 is equal to 18. Now, what is x1?
0.
0. So this term will become 0. I don't have to worry about that. x2, we are trying to figure out x2. So I can't take any value. I'm just leaving it as it is. So this equation becomes 0 plus 2x2 plus x5 is equal to 18. What I'm going to do is I'll keep x5 on the left side, move everything else on the right hand side. So this is 0. I don't care about that. x5 is equal to 18 minus 2x2. Is non-negativity constraint applicable to x5?
Yes.
Yes.
The answer is yes. So
X2 can be
I can say that x5 has to be greater than equal to 0. So now I can write x5 is 18 minus 2x2. 18
Yeah.
minus 2x2 has to be greater than equal to 0. Correct?
Yes.
So therefore 18 has to be greater than equal to 2x2.
Yes.
Yeah. So
If I
x2 has to
divide
be
both sides by
less
2,
than-
I end up getting 9 has to be greater than equal to x2. That means x2 has to be smaller than equal to 9. So if I go beyond 9, x5 will become negative, right?
Yeah.
Yeah.
Right? Now you guys tell me, these are the constraints. x2, one equation is telling me x2 has to be less than equal to 6. Another equation is telling me x2 has to be less than equal to 9. So what is the value or maximum value of x2 I can take?
6.
Obviously 6, because if I take 7 or 8, this condition will be satisfied, but we will be violating this condition and we will get value of x4 to be negative. You all agree with me?
Yes,
So
sir.
this is how we decide what should be the value of x2 and which variable. So x2 is becoming 6 in this equation. That means x4 is the variable which should become now non-basic, right? x4 will become 0, right? When I take x2 is equal to 6. Are you understanding this?
Yes, sir.
Yes.
So why
Yes.
not we are taking x2 equals 5?
Why not? Why not be taking x2 equal to 5? Okay. Anybody can anyone answer this?
So x4 will not zero. Will not
No,
be zero.
that's okay. That's okay. But in general, what is our
But we
objective?
want the
What is our
maximum
objective?
possible value.
Maximize the profit.
Maximum value of z.
Correct. And if you want a maximum value of z, you should try to take the maximum value of x1 and x2. So
Okay,
if
sir.
I am able to take 6 values of x2, why should I take 5? Because that will hamper my profitability function, right? My objective. Okay, that's the reason I am going for maximum value. Okay,
And
great. Yes.
sorry, but can we just can't we just do like we insert the value of x2 as 6 in the third equation?
Insert the value of 6
Like
in
we will
third
get some
equation.
value for x5, like, but we have to get
Yeah.
0, so we're doing it in the second. That's the reason. That's the only reason, right?
That's the only reason. Yes. So from 2 equations, I got 2 limiting conditions, and then I have to make sure I select a value in such a way that both equations are satisfied. So as we said, if we take 7, this equation will be satisfied, but then this equation will not be satisfied. This will make x4 negative, and therefore I can't go beyond 6. Okay. Yeah. Now what we have identified that x2 is going to move out of non-basic, and x4 is going to replace that. So x2 and x4, we have to swap them from their respective position. Correct? Okay.
Yeah.
Now, very interesting point, and the knowledge which you have about matrices you will have to use here. Look at this. x4 has to move out, right? So I'm just marking this, highlighting this. Now, if I'm getting x2 into this system of equation, into these basic variables, if the coefficients of x2 are 0, 0, 1, 0, then whatever is the right hand side, that will give me the answer directly. Do you understand what I'm trying to say?
So can you repeat?
I will repeat. See, as of now, what are the coefficients of x4? 0, 0, 1, 0. And because of this, I was able to, because of this entire structure, I was able to directly say x3 is equal to 4, x4 is equal to 12, and x5 is equal to 18, right? Because of this identity matrix here. Now things are changing. What change is happening? This x4 is going away and it will be replaced with what? x2. Agree?
Yes, sir.
Okay. What are the coefficients of x2 as of now?
-5, 0, 2, 2.
And 2, 2, right? If I want this x2 to come and sit in place of x4, what I want to do is I want to make the coefficient of x2 same as coefficient of x4. What are the coefficient of x4?
0, 0, 1,
0, 1, 0.
We are swapping the columns.
No, we are not swapping the columns. We have to do elementary row transformations. Okay. You know elementary row transformations,
Yes,
right?
sir.
We know
From the
elementary
one.
row transformation. So how do we deal with that? What is the first thing that we do?
Make the required thing 1.
We make this 1.
The second
So
column.
corresponding is this, right?
Divide.
So we
divide-
have to make this 1. How are we going to do that? This is
Divide
row
by
2, right? We call this as row 2, row 0, row 1, row 2, row 3. So can I say I have to do row 2 divided by 2?
Yes.
You agree with me?
Yes, sir.
Okay. So should we do that transformation on the next slide, because we might run out of space here.
Sir,
Sir,
instead
now-
of doing matrix transformation, can we substitute value of x4 and x1 as 0 and solve.
No. Stick to the matrix transformation.
Even if we swap the columns,
yes.
RHS would stay same, right?
No, we are not going to actually swap the columns, but we are going to manipulate the coefficients so that the coefficients of x2 become 0, 0, 1, 0. Okay, everybody clear? Sorry?
Can you repeat how you chose x2 as the
leaving variable and x4 as the entry? Okay, so whatever, or other way around.
No, why not x1?
Why not x1? Okay, can somebody answer why are we not selecting
Sir, can I
x1?
tell?
Yeah, go ahead.
Sir, by increasing a coefficient of x2 by 1, the profit is increased by 5, maximize z. But if we do that to x1, z only increases by 3. So
Correct.
we should
And
take optimum.
Correct. And
That's
we want,
x2.
what is our objective? We want to make maximum profit. So for making maximum profit, I should increase the value of that variable, which will give me more profit. And that's the reason we decided to go ahead with x2. Is it now clear?
So it's our choice, right? Like depending on the situation.
Yeah, depending on the situation. Yes.
Yes, sir. Okay.
Okay. Fine. Now I will just copy this table to the next screen so that we can work on the transformations. Okay.
So the transformations have to be done to the only column x2 and x4, right? Not the whole row.
When we do transformation, we do that on the entire matrix. Okay.
Oh,
Yeah, we do that on the entire matrix. So because then only everything will get manipulated simultaneously.
yeah. Got it.
So okay, this is our original matrix from the last step. Okay, now let's start with the manipulations. Let me first write down what we need to do. Okay, first manipulation, we want to make this as 1, right? We are trying to replicate this 0, 0, 1, 0 in this column. Okay, for x2. So first thing, we make this 2. So can I, this is in the second row, right? So can I say what we are going to do is R2. Can somebody tell me? R2 equal to
R2
divided by 2.
Right? That's the first step, right? That's the first step. Should we do that step first and then maybe write down the next? Okay. Okay. So let's I'll make a new table.
Copy the matrix and not like write the one.
No. let's write down the new one. That's okay. Fine. So I start with C, x1, x2, x3, x4, x5, and then we have our right hand side. Okay. Okay. So equation 0. So row 0, row 1, row 2, and row 3. Okay. Let's whatever we are manipulating, let's enter that first. We are manipulating row 2. Okay, so you guys need to help me with the elements of row 2. Row 2 is here. 0 divided by 2.
0, 1, 0, 1
Oh,
by
slowly.
2,
Hello, slowly. 0 divided by 2, 0. 2 divided by 2, 1. 0 divided by 2, 0. 1 divided by 2,
1 by 2.
0 divided by 2,
0.
12
6.
divided by 2,
6.
6. Okay, fine. What next? We have to let's start from the top. Okay, I want to make this 0. So this is 0. So I want to make this 0, right? And now remember, do you remember that we have to use this new R2, right? Because we have made this 1, correct? So we have to make use of
Plus
this row.
R2.
So 1
Plus
minute, I will
R2.
write, we are modifying R0. So R0 is going to be R0, we have negative 5 here, plus 5 times, I'm not writing R2, but I'm writing R2 new. Why? Because this is my R2 new. Now, I'm not creating another table. We are doing everything in one table. Therefore, I'm just writing R2 new so that we remember that we have to refer to this row. Okay, fine. Let's go ahead now. What we are doing, 5 times R2 new, and then we are adding that to R0. Okay, so 5 times of 0, 0, add that to 1. So 1 plus 0.
1.
0.
Hey, 1 plus
Oh,
0.
yeah,
Hello,
okay.
1, right? Okay. Again, 5 times 0 is 0 and add that to negative 3. Negative 3 plus 0. Negative 3. Okay. 5 times 1 is 5. Add that to this negative 5. 5 plus negative 5.
0.
5 times 0 is 0. Add that to this 0. 0 plus 0.
0.
0. Okay. 5 times half. 5 by 2. Add 5 by 2 to 0. 0 plus 5 by 2. 5 by 2. Okay. 5 times 0 is 0. 0 plus 0.
0.
0. Okay. The right hand side. 5
0.
times 6. Oh, we have 6 here. 5 times 6 is
30.
30. 30 plus this 0.
30.
30.
Do you understand? Now we got the value of z directly in the table on the right hand side. For this solution, what is z? Z is equal to 30, right?
Yes, sir.
Okay. Now let's work with, let's look at the next. We want this also 0. Oh, we already have this 0, right? We don't need to do anything. Just copy these elements as it is for row 1. So 0, 1, 0. 0, 1.
Sir, how do we know that the value of z is 30 for this?
The first equation is for z. The 0th equation is for z.
Yes, sir, I got it because x1 and x4 are
Correct.
0. So.
Correct. Okay. So 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, and on the right hand side we have 4. Okay. What about 1 minute? Let me finish this. What about this? We need 0 here. And what do we have? 2. Okay. So we need to modify this. So the transformation will become R3 equals to R3 minus, we have 2 here. So 2 times R2 new. Why 2? Because we have 1 here, right?
Okay. Yes.
Clear? We are referring to this row. Remember, we are making use of this row, right? So if I have to get rid of this 2, I will multiply it by 2. 1 into 2 is 2, and then 2 minus 2 becomes 0. Clear? Yes or no? Hello?
Yes.
Yes. Okay. So let's do this. 2 times R2 new. So 2 times 0 is 0. And you have to subtract that 0 from this value. So 0 minus 0?
0.
That's 0. 2 times 0 is again 0. You have to subtract this 0 from 3. 3 minus 0? 3. 2 times 1 is 2. Subtract that from this 2. 2 minus 2?
0.
0. Okay. 2 times 0 is 0. Subtract 0 from 0. 0 minus 0?
0.
0. Okay. 2 times half is
1.
1.
Subtract that 1 from the corresponding element here, 0. So 0 minus 1? Minus 1. Very good. 2 times 0 is 0. Subtract that from corresponding element. 1.
We'll get 1.
1 minus 0? Positive 1. Okay. 2 times 6 is 12. Subtract that from corresponding element. 18 minus 12?
6.
Okay. So we got our new table. We got the value of z for this step. Z is equal to 30. Okay. And what is this solution, by the way? Which are the non-basic variables? Can somebody tell me now? In this case?
X1 and X2, X3 and X5.
Non-basic. I'm asking non-basic.
Sir, X1 and X4.
We can ignore their coefficients and then we'll
Yes,
get the
yeah, we can
values
ignore,
for-
but X1 and X4 are non-basic, so we know they are equal to 0. Agree? They're equal to 0, right? And the basic variables are X2, X3, and X5. Now, can you just look at each row quickly and tell me this first row?
Sir, X2 is 6, X3 is 4, and X5 is also 6.
What is this row? This row is giving you solution for which variable?
X3.
X3, right? So X3, I will write down that here as X3. So this is giving me X3 is equal to 4, right? What this row is giving you solution
X2.
for? X2. Why? Because X2 is 1. We made that 1 here, right? 0, 0, 1, 0. Okay. So X2 is equal to 6, right? And the third row is giving you
X5 is
solution
equal
for
to
X5.
6.
X5 is equal to 6, right? This is giving me X2. Yes.
Sir, could you just repeat how did you take x4 as 0? Why not x5 as 0?
Oh, we did that in the previous slide, right? We first decided which variable we are going to move out. So x2, we decided we have to increase x2. And if we are in moving out x2 from non-basic, we wanted to know which variable from the
Okay, so
basic.
from these two equations we
Yeah. Okay, fine. So far, so good. Now the next step. What is z? Z is equal to 30. And what is the point we are talking about? The point, tell me the coefficient.
0,
0, x1 is 0, x2 is
6,
x3 is
4,
4, x4 is
0,
0, x5 is
6.
6. So at this point, the profitability is 30. Z is equal to 30. Now the question is this an optimal solution? The answer is no. And for that, pay attention. You don't need to think much. You just need to pay attention to the row of Z, the 0th row. As long as you have negative value in this row, you still have chance for improving. Are you understanding my point?
Yeah.
This -3 is telling me that, oh, I can increase the quantity of x1 and I can further increase my profitability.
Sir, so if all numbers in row 0 are non-negative, then it is optimal.
Then it is optimal. We have to stop. Very good.
So in all
Very
cases,
good.
all questions.
Yes, in all questions. Okay. So the moment all the numbers, all the coefficients in row 1 become either 0 or not positive, okay, we say this is the optimal solution. We have to stop now. Everybody clear about this part? Okay.
Yes.
Now,
Sir?
Yes.
Sorry, but can you just explain this last part once again?
Sure. So at the end of this step, we can declare that Z is equal to 30. Do you agree with that?
Yes.
Yes.
Okay. And what is the solution? 0,
Sir, if I
6,
have doubts
4,
regarding this,
0,
can I ask
6.
it in the help session?
Yeah, sure, you can. Okay, so this is the solution, right? Now we ask a question to ourselves: is this an optimal solution? So for verifying that, if anyone is getting tired, not able to concentrate, and if you want to leave the session, feel free to leave. Okay, you don't need to ask permission from me. Now, is there further opportunity to increase your profit? The answer is yes. If I increase the quantity of x1, the profit is going to increase. And what did I say? In the first row, or rather the 0th row, as long as any of the element is negative, you have an opportunity to increase the profit. Look at the first table. 2 elements were negative. So we can increase the value of, we decided to increase the value of x2. Okay. In the next iteration, x1 value in this 0th row is still negative. That this tells you that there is still chance of improving your profitability. The moment all the values become either 0 or positive, we say, oh, we can't increase this any further. We have to stop. Okay, clear?
Yes. So we'll have to make x1 as basic.
Very good. As of now, x1 is non-basic. Now I can't keep x1 as non-basic. Why? Because non-basic variable must have value 0, and now I want to increase the value of x1. That means which variable is going to move out of non-basic? The answer is x1. Everybody agree with that? So
yes,
I want to move this out. Now the next question will be, which variable from basic should become non-basic?
X3. X3.
Yeah, 1 minute. Now I just want to give you a simple idea for that. Whatever calculation we have done here, just try to understand this part. See. So what is this? This is copied from the, okay, fine. I'm introducing another column here, and you guys please pay attention. I'm calling it as some kind of ratio. What is this ratio? We'll speak about it later. Okay. So let me write down. So this ratio is nothing but the right hand side divided by coefficient of outgoing variable. Okay, so in this previous step, x2 variable went out from non-basic. You agree?
Yes,
Which
sir.
variable went out from non-basic? x2, right? Okay, so if I want to calculate this ratio for each of these row, okay, what is the right hand side?
4 and x2 is 0, so we cannot
x2 is 0,
calculate.
so we cannot calculate this. Okay, so we can calculate this only for the positive values, strictly positive values of x2. Okay, for this one, what is the right hand side?
Minus 12 or
Minus
12.
Oh, no, minus 12. This is positive 12.
Or 12, yes, 12.
Yeah, divided by what is the coefficient of x2?
2.
12 divided by 2 gives you 6. Okay, what about the last row? Our right hand side?
18.
What is the
Divide by
coefficient?
2, 9. Divide by 2, 9.
Aren't these values same as what we did here?
Yes, sir.
Right? So and what did we select? We select 6. So what do we say? You take the minimum value of this. This will tell you which variable has to move, and this was referring to x4, right? So we decide that x4 is the new variable which will become non-basic. Are you understanding this? A quicker way of doing, instead of doing all these things, we can do that with a simple, and this is called minimum ratio test. Are you all clear about this? This is called minimum ratio test. What do we do in this? You take the right hand side of that, divide that by the coefficient of the outgoing variable, but only take positive values. If it is 0, you just ignore that. Everybody clear? So for the
we have
next
to ignore negative value also.
Negative value as well. Only take strictly positive values. Okay. Now, can we use this idea for our next step?
Yes, sir.
For deciding, we have already decided that x1 is going to move out. I need some space, so I'm please erasing this. Allow me, because I will write down that ratio quickly here.
Can you move to previous slide so that I can?
Yeah, sure.
So it is 4 and 2. So we should take.
Yeah, 1 minute. Yeah. Okay. You can take the screenshot, please. Those who want to copy anything, quickly take the screenshot.
Yes, sir,
okay.
thank you.
Going to the next one. Now I'm introducing that column of test ratio. Okay. Ratio. What is that ratio? We don't do that for the 0th row. Okay. The ratio is right hand side upon the coefficient of the outgoing variable. So what is outgoing now? x1. So for the first row,
4,
what is the
4 upon 1, 4.
1 is the coefficient, positive coefficient. So I can take that. What is the right hand side? 4. Divide that by 1. What value do you get? 4. Okay. Can I do that for the second row?
No,
because
it's 0.
the value coefficient is 0. So we can't do that. Then the coefficient is 3. Okay. So
6 divided by 3, 2.
Right hand side is 6. 6 divided by 3 becomes 2. So which one is the minimum value?
The last one,
this
x5.
Is the minimum value. So that means which variable will go out from the basic? X5 will go out from the basic. Is this clear? So this is how we can quickly decide which variable has to move out.
So we have to make the last row of x1 1.
Exactly. Now you tell me, what are you going to do? What is the coefficients of x5?
0, 0, 0, 1.
Okay, and you are going to change coefficients of x1. What is the coefficient of x1? -3, 1, 0, and 3.
0.
You need to make this as 0, 0, 0, 1, same as coefficient of x5. Are you understanding? Are you all with me?
Yes, sir.
Until now? That's going to be our last step. Okay, so let's quickly do that, and then we are done. 1 minute. I'll just copy this table, and so that we can use that on the next screen. I don't need this anyway. Okay. So let's start. I will first make the table and then you guys can help me with the transformations. Okay. Okay. Let's keep this space for the transformations. So z, x1, x2, x3, x4, x5, and then we have right hand side. Okay, and zeroth equation, first equation, second equation, third equation. Okay, which variable are non-basic? Which variables are going to be non-basic? X4 is going to be non-basic and X5, right? So I'm just putting circle around there. Okay, now let's start. So what is the first thing that you will do? Getting one.
Divide by
one.
R5 is equal to R5 by divided by 3.
That's R3. We have to divide.
Yes,
we have to
R3.
make this one. So the transformation is R3 equals to R3 divided by 3, right? So let's fill that row first. 0 divided by 3, that's 0. 3 divided by 3, that's 1. 0 divided by 3, 0. 0 divided by 3, again 0. Minus 1 divided by 3, minus 1 by 3. 1 divided by 3, that's 1 by 3.
And 2.
6 divided by 3 is nothing but 2. Okay. Now, next, we can start from top maybe. Okay, we need the 0. We have a negative 3 here. So tell me what transformation.
R0 is equal to R0
plus 3 times
3 into R3 new.
Very good, R3 new. So I'm going to multiply by 3 to the R3 new element, and then I'm going to add that to the 0th column element. Okay, 0th
1
element.
will remain 1.
So 3 times 0 is 0. 0 plus 1, 1. 3 times 1 is 3. 3 plus negative 3, 0.
0.
3 times 0 is 0. 0 plus 0, 0.
0.
3 times 0 is 0. 0 plus 0, 0. 3 times minus 1 by 3 will become minus 1. And
minus
if you add
1 by
that
2.
minus 1 to 5 by 2. Okay. Maybe minus 1 plus 5 by 2.
3 by 2, na? 3 by 2.
Yes,
by 2.
positive 3 by 2, right? 3 by 2.
Yeah.
Okay. Then 3 times 1 by 3, that gives you 1.
1.
And
Plus
you
0
add
is
that
1.
to 0. 0 plus 1, 1.
1.
Okay. 3 times 2, 6. And you add that 6 to this 36. You see, we got the probability.
Yes, sir.
Right? Correct. Very good. Let's move to the next one. I want to make this 0. What do I have here? 1. So we can simply subtract R3 new from this, right? Because we have already made this 1. So what transformation I will use? R1 equal to
Give R1 minus R3 new.
R3 new. That's it. Okay. So let's go step by step. 0 minus 0, that's 0. 1 minus 1, that's 0. 0 minus 0, 0. 1 minus 0, 1. 0 minus minus 3. That means 0 plus 1 by 3. Not minus 3, 1 by 3. Sorry. So 1 by 3. Positive 1 by 3. Then 0 minus 1 by 3. So negative
minus 2 by 3.
Okay, 0 minus 1 by 3.
Yes.
Minus 1 by 3.
Minus
Yeah.
1 by 3.
Okay, then 4 minus 2. 4 minus 2 is 2. Right? Okay. Then we need 0 here. And we already have 0, right? So I can just simply copy this row. 0, 0, 0, 0, 1,
1 0 1 by 2.
1 by 2,
0
0,
6.
and 6. Now look at the row of Z. Do we have
That
any
is-
negative values? Negative
No.
values?
Yes.
No. That means this is the optimum solution. We have to stop here, right?
Okay, sir.
And So are you all clear about this? So what is
Yes,
the
sir.
optimum solution?
Sir.
Z is equal to
Z
36.
equal to
Got the value
36.
directly.
2, x2
And
equal
please
to
tell me the
6,
point.
and
X1 is equal to? Oh, 1
X1
minute. Now
is
1 minute.
equal
1 minute.
to
1 minute. 1
2.
minute. 1 minute. 1 minute. X3 is here. X2 is in this row, and we replaced X5 with X1. So X1 is going to be here. Okay, now tell me.
Yes, sir.
What is X1?
2.
X1 is equal to 2. What is X2?
6.
Which is the
What is
exact
X3?
same.
2.
What is
X4,
X4 and
X5
X5?
0. 0, 0.
Did we get the same solution? 2,
Yes,
6?
sir.
Right?
Yes, sir.
Okay. So why did I do all these things? Just to make you understand the logic of steps which are followed in simplex. Are you all clear about every step that we followed here and what's the logic behind it? Okay. Tomorrow we will do this problem with the simplex method, and just let me just give you an perspective. I want, can you all quickly take the screenshot of this? Everybody please take the screenshot.
Yes, sir.
Okay, I want you guys to keep 4 copies of this ready. So if you are using a fullscape size page of notebook or whatever your long notebook, so one page should have one such table. Okay,
Yes.
like that I want you to have 4 such tables. And tomorrow this whole thing what we have done here, okay, we will be solving in this one table, just one table, and that's what is simplex method all about.
Sir,
Okay,
but we have to make 4 copies, right? So 4 tables.
copies, yeah, one paper for this, maybe keep some extra copies, and if time permit we will try to solve one new question using this. Okay.
Excuse me, sir. Can you,
Yes.
go to previous slide a minute.
Yeah, sure. So I hope everyone has taken screenshot. I want you to be ready with this tomorrow. Yeah.
Yes.
Yeah. Which
The last.
this one? This one?
Yes,
This
yes,
one?
sir.
Yeah.
Because here X3 is 2.
X3 is 2. Yes, you are right.
Okay, so
X3
then
is 2.
okay. Then X4 and X3 are non-basic, so they are 0.
Yeah, they are 0. They become 0. Okay,
Sir,
they
can you
become 0.
show the
Table, I will show it again. Okay.
Sir, will you upload this annotated one to
Yeah,
the-
I will upload the annotated slides even today. Don't worry.
Sir,
Yes.
sir, can you please quickly explain like what is the point of non-basic values?
Non-basic. See, when we have a system of equation, like in our case, we have only 3 equations. Okay, those. Okay, these 3. Okay, these 3 equations. And how many variables are there? X1, X2, X3, X4, X5. 5 variables. Now I can't solve this system of equation when I have 5 variables and 3 equations. So the difference between the number of variables and number of equations is how many? 2. 5 minus 3, 2. So I have to assume the value of 2 variables. Then only I will be able to solve this system of equation. And that is called degree of freedom. And those 2 variables for which we are going to assume the value, we call them non-basic variables. And as a rule in simplex, we are allowed to assume any arbitrary value. So in simplex, we assume that value to be 0. Okay.
So we
Yes, sir. Thank you, sir.
Yeah.
so
Yes,
we get
Kavinian.
X3 as 2. Then what does it say?
Oh, what does it say? We don't care about that. For us, we are interested in values of x1 and x2.
Okay.
We have introduced those slack variables so that, okay, if x3 is equal to 2, x3 is equal to 2, what does that tell me? Why x3 is 2? Because x1 is equal to 2. Right? So 2 plus 2 is equal to 4. That's my first equation. But that does not have any impact on my profitability. Why? Because is x3 present in the profit function?
No, sir.
It's not there. So it doesn't matter for us. Whatever be the value of x2, x3, x4, x5, it is not going to hamper my profit function. So I don't care about that. It's a slack variable. Okay. Okay, guys.
Sir, in
Thank you so much.
methods, geometry way is easier or algebra way? This way is easier.
See, again, I'm telling you that the problem which we are doing is simple, right? A very small problem. So when we did that in a geometric way, it is very much easier to handle such kind of problem in geometric way. But when we think about the real life situation, the problems are very, very complex. Now we are just dealing with 3 equations. Maybe there are 10 variables or 12 variables or 15 variables. When we have to do that kind of problem, we can't really use any graphical method for that. We have to go for algebraic way of solving. And of course, that is again done by computers. No need to do that manually. And therefore, you need to understand. As far as academics is concerned, you guys are going to get a similar kind of problem because you will be solving using graphical. Fine?
Yes, sir.
Okay. Okay, guys. Yes, Shriram. Yes, Shriram.
No, I just wanted to tell if anyone has any more doubts. We have a doubts clearing session today. So
Yeah. Is that
you
a
can
common
ask
session
them.
for A and B? Is that a common session
No,
for A?
it is
No.
only for A.
A, only for A. Yes, yes, yes. Okay, anyway, so we will stop now. Guys, thank you very much for your patience and allowing me to extend this session by 40 minutes. I appreciate your patience. Okay, so thanks a lot.
Bye, sir.
See you again tomorrow, guys.
Thank you, sir. Bye,
Thank
sir.
you, sir.
Bye,
Bye.
sir.